Hello, we're going to demonstrate the first part of the seminar. We use the first command to launch a robot with gazebo in an environment. Here's the environment that you usually would see, and with your mouse you can spin around, use the shift to get some perspective if you want, get closer, grab the environment until you are somewhat happy of what you want to see. Then in another terminal here, we launch the command and we have the capacity to keyboard arrows, our acceleration. So you click once and you're moving forward, you click another time and the velocity has been incremented. And so on the back arrow, if I click it twice, it stops the robot. As you can see, I can go backwards faster by accelerating and then forwards to slow it down until it's almost zero. So sometimes it's hard to tell. Similarly with the arrows that give velocities to spin around. So what we want you to is to have some practice with navigating with this robot around obstacles. Sometimes it's easier for them on top view. All right, and the hard part here, for example, is to remember how many clicks did I give it in one direction. All right, so now it seems to be going straight. Maybe one wants to stop it, go a little bit to the left, stop it. So here we restart gazebo, reposition our world so we can see it, and we start the teleoperation, and we also are going to start the application you see here. The application, the example of Ross on how to record a map. We go back to the window of teleoperation, and in this fast forward video, we teleoperate the robot around the environment in order to record a map. We go around several obstacles using the arrows of the keyboard as we did earlier, but now a map is being recorded from readings of the odometry and the sonar. I'm going around several of the obstacles here, and then eventually I'm going to stop. When you decide to stop, we choose this window to run the ROS now that actually saves the map. So this is the call that saves the map. Okay, so what we're going to do now is use the navigation tools of ROS. So I started Gazebo again, and I'm starting RBIS, so you can see that when I load a map, RBIS is going to show us the map. So in this case, we load the application and the demo, and we see here the map. Now I'm going to spin around the image of RBIS and make it a bit smaller and run around so our RBIS frame of reference matches the frame of reference of our scene. And as you can see here, if you don't need to use the teleoperation, but I'm using it to show you that RBIS reflects also the sonar sensor. So we see the purple area almost disappear and the bookshelf appear for a while, and then as I move forward. Now I'm doing this actually, I'm going to close RBIS and the map application, and I'm going to move the robot with the teleoperation to a very different initial position for the navigation, something that is not the default of when ROS starts the world and when RBIS starts. So I'm bringing the robot very close to the white block as you see here, and I'm also going to spin it so it's oriented towards the bookshelf. So I'm making sure that it looks to the bookshelf, so I have a very different initial situation. Now I will restart RBIS. Again, RBIS shows me the map and the sonar sensor, but as you can see now, it's very discordant what our BIS can see, because actually this is the bookshelf. So what we're going to use is this arrow to define the initial position. So I'm playing around a little bit to make sure that I have the robot very close to the white block and also looking towards the bookshelf, so more or less the sonar sensor matches the map at the bookshelf, and I'm reasonably happy that this is the initial position. Now I define the final position, and I'm going to make it far on the other end and looking down at the other object. So you're going to see a green arrow that says that's my target position, and as soon as I do that, the motion planning application starts to move the robot around. And as you can see, the robot travels by first spinning on itself and then going forwards and recognizing other landmarks in the environment. So recognize the cylinder as it travels closely. It's going to get to the final position, and then it's going to spin downwards, because the orientation is not only, the pose is not only the position, but it's also where it's looking.